Okay, good afternoon. I'm going to start on time, and I know there's a few people still coming in, but I want to be respectful of the next session slot after me. So we'll get started. Thank you for joining me after lunch. I hope you're all well fueled up for the rest of the afternoon and anything else that you have planned for this evening. Today we're going to go through fundamentals of Windows containers and Windows container-based apps on Azure App Service. So my name is Andrew Westgarth, and I am a Senior Program Manager on Azure App Service. I've been with the team for about 4 years. Previous to that, I was an IIS MVP for 8 years and worked in enterprise in the UK. Everything from small business all the way up to FTSE 100 companies on the cloud. So I've been working the web hosting sphere for quite some time. Principally, I tend to work on our on-premise products of Azure App Service. So I own App Service on Azure Stack, the previous version Azure Pack websites and things like that. And now I'm looking at Windows containers on Azure App Service based on some work that we did with bringing a preview of Azure Functions on-prem last year. Okay. So Azure App Service is our large-scale hosting platform within Azure, and it offers high productivity to developers. Our goal here is to accelerate development of features inside applications so that you don't have to worry about the underlying infrastructure, and as a development and engineering team that you're adding value to your customers and your business with each release. We do that by enabling you to use existing languages, CI/CD tooling, pipelines that you're familiar with, and we've got a great raft of diagnostics capabilities inside the platform. Some of those will be drilled into in a session at 4 o'clock by my colleague Jennifer Lee. And if that's something that is really interesting to you on the App Service platform, I do recommend that session as a follow-on. Azure App Service is fully managed. It's a fully managed platform as a service offering. We're into our 5th, 6th year, and we manage the underlying infrastructure. We make sure that it's patched, it's up, it's running, and everything else underneath the covers is taken care of. And we're enterprise grade. We meet stringent compliance requirements. We are certified for a number of different certifications, and we go through that along with the other Azure services on a regular basis, and that therefore also takes over one of the headaches for yourselves to get your hosting environments compliant. We are already there. So to drill into just a couple of those key pillars that I went into. So high productivity, we support everything from .NET, Node, Java. We now support Docker. We supported Docker containers on Linux for quite some time, and Windows Containers is our new offering that we announced in private preview in May, a build. We made some big announcements around Java recently, PHP support, Ruby, Python. We have staging and development deployment slots so that you can stage environments and swap between when you want to go from dev test into production. Testing in production, being able to route some traffic via A/B testing, that sort of route. And we've got a large gallery of applications on the platform. But some of the benefits of being on a fully managed platform, you get auto-scaling and load balancing. We take care of the load balancing algorithm, and we take care of auto-scaling your instances out depending on your rules. So your application's hitting high CPU. Okay, we want to go to 2 instances. We want to go to 10 instances. You're hitting memory limits. Okay, let's scale it out and do some more. You can scale out or scale up in a matter of minutes in a couple of clicks or in an ARM template. No longer are you waiting for IT to procure and provision new machines. We can provide you with a global stamp that's got capacity for you to scale out. We're HA, we're 99.95, even with a single instance. We maintain that SLA for you. We reduce your ops costs in terms of your CapEx expenditure and managing that infrastructure and free up your staff to add more value in other ways. We are truly global. We are one of the, I think, rough count, we're the 4th/5th service that goes into any Azure data center. We are there as soon as compute, network, storage, and SQL land, then we arrive. We've got support for hybrid workloads, whether you're on-premise resources that you need to reach into, or in another data center, we can support that. Deep integration with AAD, and we're heavily secure and compliant. 575,000 customers are actively using us with over 1.8 million apps and sites hosted, and we're handling over 24 billion requests per day. On the pre-day, I got the question, would I ever host anything that's more than dev test on Azure App Service? I think our figures stand for ourselves. We're running 800,000 VMs globally, and we've got a large number of customers running production workloads, and some of the examples are up on the screen. So those familiar in the US, Jet.com, they host their e-commerce platform on top of us. Let me think. We've got government sites from various places around the world. We've done the Canadian elections, the Eurovision Song Contest, Nobel Peace Prize. We've got a wide variety of different applications and workloads running on top of the platform. So you can be confident in what you're using. So why did we add Windows container support onto Azure App Service? We looked at our customer base, and we looked at opportunities where containers will help with some key scenarios. And the key scenarios that we're looking at is lift and shift direct to PaaS. So we've gone past the stage where customers want to lift and shift into an IaaS VM and manage and host that environment and deal with it. They're now looking at the benefits in PaaS, but they're not quite ready to go to full PaaS. They can't make too many changes to their application, but they do want to take advantage of global scale, auto-scaling, deployment slots, easy authentication, a lot of the things that we've got built into the platform. So by being able to simply containerize an application and run it within Azure App Service, it does give the benefits of lift and shift with all the bells and whistles that we have as platform as a service. Azure App Service, by default, runs in a sandbox, and it's our proprietary sandbox technology, and we don't allow certain things to happen. One of the things is being a platform as a service, we don't allow you to have access to the host VM itself. So no longer can you install libraries into the GAC, install custom cultures, install, say, client libraries, component libraries, database connections, sort of stuff, and we don't allow that. But now in a container, the actual host environment is your container, so the sandbox becomes the container. So now you've got free reign to install components into your container, and it's your container as the isolation boundary. In addition to that, we do block certain APIs inside our sandbox. So the traditional APIs that often customers hit up against are GDI-based libraries, drawing libraries. A key example of that is PDF generation by URL. We did used to have problems with reporting services. We relaxed our sandbox slightly to enable reporting services in Azure, but it doesn't cover all the bases for all customers. So by working inside a container, you're not blocked by that same sandbox. Data center migration. How many of us have worked with a company who are looking at moving data center or have applications written by third parties that they don't have any relationships with, but they need to move away from the existing infrastructure, they need to move to something new, and they don't want to sign another on-premise data center infrastructure lease. So this gives us an opportunity to help customers with data center migration plans, thinking forward, things like 2008 R2 end of life next year. What's your plan for that as a business? What can we do to help with that? And then last but not least, .NET Core applications. We've been able to host .NET Core applications in Linux containers for quite some time, but there are organizations and use cases where customers do actually need to be in the Windows environment, so therefore need to be in our Windows container. Within Azure App Service, we have this brand SKU, term it whichever you wish, called Web App for Containers, and it's an entry point for customers who are deploying applications with inside containers. And this gives a number of different capabilities on top of the base platform that we already have. So tight integration with Docker Hub, Azure Container Registry. You can also bring your own container registry. You're not required to use those two. You can host yours off-site. As long as it's accessible to us over the web, then we're okay. Built-in CI/CD with deployment slots, you get the benefit of the platform there. Intelligent diagnostics, the diagnostics that I alluded to earlier, you get the benefit of that straight away by deploying on top of our platform, and then the others are key there. But the container workload, because often you're bringing a custom container, it opens up the breadth of stacks that you can work with. So our blessed OSs are those that we support purely from a code or from a blessed image with Linux containers. Linux containers have an option to bring your own container, and Windows containers right now are only in the implementation of bring your own container. You bring a custom container with a custom OS underneath, and then we run your workload with inside that. That therefore opens it up for you to go and look at other application stacks that we don't necessarily support by default. One that I can think of based on my past history is Cold Fusion. We don't have support for Cold Fusion on the platform, but with a custom container, then that may be something that you could look at. It was back in 2000 when I was doing Cold Fusion development, and it was on Linux. But there we go, we were Red Hat 4.5.2 or something like that. But, you know, those applications still exist. You know, if it's not broke, don't fix it. So we know that these applications exist in organizations and in enterprise. So with custom containers, we can bring these workloads forward with us. In order to deliver Windows containers on Azure App Service, we need to light up a new SKU. And this SKU represents some of the most powerful machines that we have available today to Azure App Service customers. And they're built on the DV3 series VMs. The DV3 series VMs are the only VMs, or at least the entry-level VMs within Azure, that enable us to host Windows containers on them, because we need nested virtualization. So we need to be able to run a VM, the container, inside a VM. So that's why we need to be on DV3. PC2 offers 2 CPU and 8 gig of RAM with 50 gig local storage. And it's the local storage that's key for how many containers you're going to go onto one of those instances, because that's where your container is hosted. It's hosted on the SSD. So we go all the way up to a PC4, which is an 8-core and 32 gig of RAM with a 200 gig SSD. These are exclusive to Windows Container Apps. No other type of applications on Azure App Service can be deployed onto this SKU. It is purely for Windows Container Apps. So some of the things that you get by default, if you're familiar with App Service, this is not new, but if you're not familiar with App Service, this is something that may be of interest to you. Custom domains and SSL is there immediately. This is a premium SKU, so you get 20 instances that you can scale up to. Early in the public preview, we were free, and we had a limit of 2 instances, just because we didn't want too many people to go crazy and consume all of the limited resource that we did have in the early days of the public preview. But you can go up to 20 instances per region that you're in, per app service plan. 20 staging slots, dependent on obviously the size of your containers and how you spread those. Use Traffic Manager to distribute workloads. Your CPUs, the instance of the SKU is dedicated for you. So nobody else will be running workloads on those individual machines. So they're dedicated for you. The memory per instance, you can see it up front. That's to split across all of your containers. So there will be some form of memory management to deal with, depending on how many containers you try and pack into that individual machine. And the storage is all local SSD. There is an optional additional 250 gig of disk storage that we make available standard across all app service apps, but with the containers, your container itself wouldn't be hosted in there. It would be for other assets, that sort of thing. One of the principal things with container-based applications is that you build them off a base image. So in Windows, this becomes either a Windows Server Core image or a Windows Nano Server image. If you have an application that's based on .NET Framework, then you're immediately into a Windows Server Core image. Windows Server Nano does not enable .NET Framework, the full .NET Framework, etc., to be installed on that OS. So for support-wise, we need to be on a Windows Server Core image. If you're doing ASP.NET Core, then you can host those on Nano images, And other languages, you may be able to do that on Nano as well, and they're a lot smaller. There is a significant difference between the size of a Windows Server Core image and a Windows Server Nano image. The Windows Server team have done a fantastic job in the newer versions of Windows Server to bring those containers down. One limitation of running on Azure App Service is that we are running the long-term service in channel version of 2016. So we're not on 1709, we're not in 1803, if you're familiar with that moniker. The seasonal channel, the update channel that comes more frequently, we're not able to support those containers. So we do need to use the Server Core LTSC 2016 or the Nano Server SAC 2016. Now this slide's important because when you're building your container images and you're hosting on Azure App Service, by all means use a base image that you've customized and you've brought with you. But please build it off one of these bases. We cache these versions of the base images onto our workers to eliminate the need for that constant pull to be coming down from the container registry. The average size of a Windows Server Core image with an application on is around about 14 gig, just for a hello world. So that gives you an idea of why you should use one of these cached images that's based. So we cache the Windows Server Core LTSC 2016 latest, the Nano Server SAC 2016, and we also cache the ASP.NET 4.72 ones, both the multi-arc and the LTSC. The multi-arc ones are quite clever. They can determine the host that the container is going to run on and then pull down the right version of Windows Server, so they're quite clever. On the .NET Core, we do cache the SDK container and the runtime container, so if you want to do any build with inside your container of your .NET app, then you can do that as well. So let's do a demo. I'm going to try and do quite a few demos today, so let's hope I've sacrificed enough to the demo gods, and off we go. Whoop. Okay. So the scenario is here. I've got I'm just going to spin up a .NET Framework application, a web forms application, something common with inside most organizations. And I'm going to use 4.6, but the reason I'm doing that is because I want some of the demo pages, I want some of the scaffolding with inside there. I've got samples later that use .NET 2, but I don't get any scaffolding today in VS 2017 for V2. So today I just want something that looks a bit more graphically appealing than something I'd probably walk around with for a demo. So I'm going to choose web forms, and you'll notice on the project creation we have support for enabling Docker Compose immediately. But I don't want to go through that, because what I'm trying to do here is simulate you're in the office and you've opened up one of your existing web apps. How do we get that into a container, and how do we get that up to Azure App Service? We'll just let VS spin up this project. And now it's going to take an inordinate amount of time compared to when I rehearsed this about 20 minutes ago. But that's life, and that's what really happens. So it's a very straightforward step for us to be able to take this web app and just add Docker support. So I'm going to go back into the web app. And I am on the very latest update of VS 2017. So the menu option may be slightly different on the version that you're running. You will either see add container orchestrator support, or you will see add Docker support, depending on how recent your version is of Visual Studio. And if you don't see that option, it tends to be because you don't have the .NET Core payload installed inside Visual Studio. So go into the Visual Studio installer, modify your install, check that box, and then you will get the Docker support built into Visual Studio, and off you go. So I'm going to choose Container Orchestrator support. We've got a little quirk in Visual Studio when we're presenting at large fonts. But you'll see two options. So Visual Studio offers you the support to be able to build your containers for Docker Compose or Service Fabric. The one we're interested in here is Docker Compose. And what Visual Studio now is doing is adding me a Docker Compose file. But more importantly, I get this thing called a Docker file. And the Docker file is where I set up the build of my container and tells me the information about the base image and where my source is going to come from and any other steps that I want to run on this container. So first thing you'll notice that my machine is using more recent build of Windows 10, which is capable of hosting the 1803 containers. Visual Studio detects which version you're capable of running in your local dev environment automatically, and then makes a decision when it's building the Docker file. For hosting on Azure App Service, we need to make one small change. So we just need to change the end of the image name to LTSC 2016, and that's just the image tag. So we have the repository, Microsoft, we have the image, ASP.NET, and then we have the server tag on the end, the 472 Windows Server Core LTSC 2016, and this enables me to host any application up until a .NET 4.7.2 application. Below that, we set an argument of source and setting the working directory within inside the container. And then what I'm doing there is I'm copying the source of my project output when I do a publish. So if we do a save, and you'll see in the output window is heavily your friend when working with Docker containers. You get a lot of output immediately to see what's going on. So I can see now that what's actually happening is Visual Studio and Docker are building my containers for my local dev environment so that I can debug directly into those, run them locally on my machine before I even decide to push up. So I just need to wait for that piece to complete, which shouldn't take too long. So there we go, we're building my new container for my sample, and once that's complete, we're going to publish, and then we'll go through and set up the web app in Azure App Service. Okay, so done, my containers are ready. Just to prove there's no smoke and mirrors, let's go into PowerShell, Docker PS. So there's the image up and running in a dev form. So I can see that that container that we've just built through that hello world is up and running on my machine. I could F5 debug, work through with the project, step in, do all my breakpoints, everything that we're used to doing as .NET developers. But what I'm going to do now is I'm just going to right-click Publish. Now I know Donovan says don't tell your friends to right-click Publish, but this is a Hello World demo and I want to give you something that you can do very quickly without having to set up a pipeline. We are going to set up a pipeline, don't worry about that. So with Azure App Service, the Visual Studio has detected I've got a web app and it's decided to give me the option, do I want to go straight to App Service, which is just publish the code and off we go? But no, in this case I actually want to do a container registry. We are working for future versions of Visual Studio to have the whole thing, so that you can publish to a registry and create the web app all within inside Visual Studio and publish. We do have that support for Linux today, but we're not quite there with the Windows containers. So we'll go into container registry, and here I get the choice of either creating a new Azure container registry, using an existing one within inside my subscription, using Docker Hub, or even publishing to a custom registry. So you as an organization decide that all your images you want to reside in your purpose-built custom registry that you host, and that's where you want to keep them. Today I'm just going to go to Docker Hub, so I need to log in to Docker Hub. And in the background now we'll be getting the publishing going. So we can see that the build's going forwards. Configuration's my release build. building that new sample. One key point to point out here, all container images have a tag, and excuse me, Visual Studio decided to, there we go. So image tag. You can, if you're working with inside Visual Studio and doing publish and just wanting to make sure everything's good before you go any further, you can edit the image tag by clicking on the link and change the image tag to anything but latest. So it could be something else that you wish to change it to. Previous versions, that wasn't possible. So that's gone through, that's published already, up to Docker Hub, so we're good. Now we're going to Visual Studio. So let's go to Docker Hub and see. Right, should be on page 2. Yep, so there's my new sample already published up. So the reason why that was so quick was because I've got other applications that use the similar layers, and all I'm really pushing up to Docker Hub is the difference. So it's able to detect, well, okay, the only things that I need to publish based on the repos is these different layers. And we'll go into layers a bit further on once we go through some fundamentals. So let's create a resource. And we'll go through to Web App for Containers. I give the application a name so that we can browse to it. I choose Windows. And now when I go through to create an app service plan, I've already got one on my subscription because I've been doing some other samples, but I want to go through the create new experience, and that's what this whole hello world's about. So let's do APW ignite hello world. Earlier in the public preview, if you have had a look at this, that we only had 2 regions. We only had West US and West Europe. Late last week, in fact at the weekend, we added an additional 5. We're now supporting Windows containers in Australia East, East US, Southeast Asia, and then we've got additional stamps in North Europe, additional capacity in West US and West Europe. And as we build the capabilities as we head towards a general release, we'll be adding more and more regions to that footprint, so we'll be available in all Azure App Service regions. So today I'm going to choose West US. Is that the closest? No, well, let's use East US. Yeah. And this is where we can dig in and we can see those SKUs that I mentioned earlier, and this is where you can choose. Okay, so we have the PC2, the PC3, the PC4, and you will see the pricing come up as well. My pricing's in Great British Pounds, which are not worth as much as they once was. Well, we'll not go into politics in this session, because everybody's got their own things to deal with. So dev test, we don't have dev test options for Windows containers. They are a premium offering right now in the public preview. We have some challenges. They are things that we're thinking about how we bring those and make it easier, the on-ramp, and different ways that we can solve that problem, but right now we don't have an answer. That's us being honest, you know, we're not hiding anything from you. We are aware of these issues and we are working on what we can do to bring them. This may head off one question that many of you have is when are Windows containers come into app service environments? Well, they're not there yet. But it is on our roadmap, but they're not there yet. So that's why you don't see any of the isolated SKUs either. The day I launched the private preview back in May, the first question I got from my private preview customers is, where are they in ACE? I can't use them until they're in ACE. I literally just took this thing out of the oven. We're not going to do ACE first. But there we go. We've heard the feedback loud and clear. We will bring them, but not right now. So I'm just going to choose a PC2, which is our smallest instance. And we go OK. And I'm going to configure my container. We do have a quick start, so if you just want to see a container app running, I just built a simple, the same thing that we're doing now, the hello world, and you can get that up and running and try it. You can use ACR, but for this one we're just going to use Docker Hub, so AP Rescart, APW, Ignite 2020, hello world, latest. Aha. So I don't know if everybody saw that. But we have validation to detect whether A, your image and your tag is correct, because we want you to fail early rather than fail at the point that we try and pull your image. There's nothing worse than having a VM spin up and wait for the process to happen and then see in the logs, they couldn't find my image. That sucks. Why don't we tell you now? So that's what we've done. We tell you that now. Also, we have an API that can tell us whether we're pulling a Windows image or a Linux image. So therefore, you don't end up deploying a Linux image into one of the Windows SKUs, and you don't vice versa pull a Windows image into the Linux SKU. So let's see what was my error, what have I done? I only called it 2018 sample. So let's go back to the portal. Excuse me. I've just been caught by a gotcha on Docker Hub. So Docker Hub is a Unix system, so it's case sensitive. So let's fix that. There we go. Apply. So that's validated. We're good to go. We've got everything set up, a new app service plan, a new resource group, new web app, and we create. What happens in the background is we go off and we create the website. We check the name in the DNS, in our DNS lookup to make sure that nobody else has got it. We provision the website on our management plane, and then we start to pull one of our workers that's available, and we make that available to your application, and then we start to do the Docker pull once the application's up and running. So that failed. Let's try it again. If this doesn't work, I've got plenty more. I'm going to choose REST-US in case it was a problem with the data center. We'll just go configure this container. Bang. Okay, let's try that. Should take about 40 seconds for the application itself to come up, and then we'll be waiting for the Windows Server Core image to spin up itself once we've done the Docker pull. So let's have a look at the deployment in progress, because I'm worried about it not actually completing this time, so I really do want to watch it. So the first thing to note, you'll see is that the deployment title is App Service Linux. And that is a legacy artifact from that gallery item, the gallery item web app for container. Underneath the hood is called the App Service Linux gallery item, and that's why you will see that in the history. Awesome, time to fail on create. Let's go just look at some demos. So that whole flow, that item when you see it in your deployment list, which is really important if you're doing ARM templates and you're doing repeated deployments, you'll start to see this thing and you'll be sitting there thinking, well, hang on a minute, I had deployed a Windows container. Why does it say I'm on Linux? Well, that's the reason why. It's just a hang around. It eventually will go away, actually, that entire entry point. So let's go back to the deck and just do a summary of what I've shown here before we move forward. So the prerequisites for that demo, for that simple hello world, is you need to have Visual Studio 2017 with .NET Core and Azure workloads installed. We install the .NET Core workload not because I want to do .NET Core development, it's because that's where the Docker support comes in into Visual Studio, so that's why that piece is key. Docker for Windows, that enables you to run Docker containers on your local machine, and that's required. The nice feature about Docker for Windows is you can switch between the two. So if you want to do Linux containers, you just switch with inside Docker, and it will enable you to do both, to switch over to Linux and then switch back to Windows, so that's quite valuable. You will need a Docker Hub account or an Azure Container Registry. So if you've got an Azure subscription, then you can spin up a container registry, or you go into Docker Hub and you can just spin up one of their their accounts and get off and running. That exact example is in the blog post that I wrote when we launched the public preview, so you can use that short link to get to that. The slides will be made available as well, obviously, on the website, so that's not an issue. So now we need to drill into what customizations can I do with inside the container. So all of those things that I said you couldn't do in standard app service, well, how do I do it in a container? How do I enable this to actually happen? So let's have a look at a few different samples that I have running. And then we'll have a look at how we do it. So one of the key things that we find customers hit up all the time, they want to generate a PDF. And they want to do it based on a URL. And often that calls into libraries that we block within our sandbox. We block them for good reason, but unfortunately it impacts components and things that customers are trying to do. And one of the key ones is PDF generation in Azure App Service from a URL base. So what I did for this demo is I built the same hello world, same ASP.NET, just blanket web application. And I did a quick search online and said, well, give me .NET components for PDF generation. And I just picked the first one. I struck gold straight away. As soon as I ran that one in traditional web apps, I got a yellow screen of death, and it was because of the sandbox limitation. However, this version is running in a container. So I'm just going to put in here my blog address. Hasn't been updated for a long, long time, but you know, a 3.5-year-old and a 1.5-year-old don't half suck your time, so you don't really get very much time to write stuff. So all that's doing is just using the bog standard boilerplate code within inside the library, just to generate the PDF, and we should see at the bottom, yep, we should see a nice PDF show up. So there we go in Adobe. So you may notice a theme on my desktop and on my chest, but there we go. And I also have, so this is the same project. This PDF sample is the project that you were viewing on the web there. And you'll notice that this project has got a Docker file in it. And before this, I actually just published to another website just so that we could prove that it's not. So if I do the same thing again, we should, unless somebody's made any changes to our sandbox that I don't know about in the last few days, should see a nice yellow screen of death. Oh, well, it depends what you feel. Most of the time you don't really want to see a yellow screen of death, but right now you should do. Please, please, please. It does seem to be taking far too long. Please don't kill my demo. Come on. Right, I'm not going to wait for that too long, but all I want to show in there we go, yellow, back. Yep. So we've got an error, and that error is when you call into that third-party library. That third-party library is then calling into something that we block in our sandbox. This is the case where you'd be opening up a support call. We'd be looking at the sandbox logs and deciding, yep, you can't call into that one. Sorry, it's our sandbox. And that's part and parcel of running on standard app service. But in that project, just to show you the Docker file, just so you know, when you guys are using Visual Studio in the office, I get the same issues. 64 gig of RAM, i7, and yeah, I still get the slowdown. So, you know, we all dog food and we all give back all the feedback, and I'm not even able to open that file. It is shared over VPN, so that may be the issue. But let's look into another sample that we have. Custom fonts. We don't allow you to install anything into our workers, so therefore we don't allow you to bring your own fonts. We don't allow you to have things like that installed on the VM. So in this example, this is rather a simple example. All I've done is I've loaded two fonts available, and what I do is I use the Docker file to inject them into the container, host the container up, and off we go. We can see these capabilities. And it may look like a simple example, but it is things that we get a lot of requests from customers to be able to install custom fonts. And unfortunately, custom fonts can be exploited, so we don't allow it, for example. So I have the fonts in my solution, which, yep, it's demo where I can see you screaming and you don't like this, and anybody who's built a solution knows that you probably don't want to be doing this. And then I go and make it even worse. I put a PowerShell file in my web directory. Yep, slap me on the wrist. I know that's not the right thing, but I want to show you a simple example, and then in the next examples we'll show it a bit more detailed. If I can give you one message about customizing your container, it is get to be very good friends with your IT pro colleagues. Those colleagues that have deep knowledge of how to customize Windows Server when they're building a VM. They have deep knowledge of PowerShell. Because often you'll spend yourself doing lots of searches to figure out how to do something. So first thing I did was I've got to install a font. How do I do that on a server core when I don't have a GUI, and how do I script it, and all these things? So the first thing I had to do is go and figure out how to do this through PowerShell. This works for me. If there's better ways, then great, but if it works for me, so that's all that mattered to me. So I added the font and the PowerShell file as content. So therefore it gets packaged up with my application and gets deployed into my container, and now I can execute those pieces and reach them. So all I have is a run command once I've done the copy. So therefore it's running inside my container, it's built as another layer, and then we can publish that container up with my customization. So that's how it looks straightforward, and it is, but that's how we did that. Let's close that version. Custom cultures. So we get this request a lot, but also the custom culture has to be installed into the base OS of a worker each time that we scale it out, and we don't enable this. We used to get it a lot more when we used to have a base of a 2012 image, because we only had certain subset of languages available to us, and a lot of customers, especially in other countries in the Far East and Asia, etc., wanted additional languages to the default set that we had in Windows. So we enable custom cultures this way. So you'll see here, it's pulling in the custom culture name. So using standard ASP.NET internationalization features, I've just set the custom culture to be that of mine. I've pulled out the name just to prove that it's not a trick. And I've modified the ENUS culture to display the data I'm familiar with. So I've been enjoying life in the United States for 2.5 years. But I still struggle with dates when I go to doctors and things like that. I still struggle with having the month first before the day, because I've spent 35 plus years working the other way. So this is just my example. So I have my custom culture code here, just to build a culture builder, build that into a library. I've modified the date pattern. I've registered a new culture. And then inside this application, I just set the default culture to be my new sample, and then use that inside the web page. But the power here is in the actual Docker file, and this is the thing that I want to get across to you here today. So instead of having that DLL as part of content inside my application, then a script to execute to actually install, what I've actually done is I've actually uploaded my dependencies up into blob storage, and then I write some PowerShell to pull them down at runtime, execute the process to install those. So I execute an exe to actually install that custom culture. And then the key thing here is I'm removing those dependencies from the container. removing that directory of where I've put those temporary dependencies is, I get rid of a layer. Containers are built of many, many layers, and that's what makes them bigger and bigger. So anything you can do to reduce the size is always golden. And you don't need that dependencies folder once you've actually done the install. You don't need it. You don't need it for running your application. You don't need it for anything else, because the base OS image, the Windows Server Core image that you use, that you build your container, has been modified by you in your Docker file by you running that script. So that script there is just pulling down a file, executing it, and then deleting that folder. And then we copy in the application source, and that's how we do that one. My samples follow a pretty similar structure, and that's because that's the way I've found that I can work with containers very simply and very easily, and that's where we go with that. So let's see if this one's spun up. If not, it would be a good demo in how to show you what to do when something goes wrong. Okay, so that hasn't spun up yet. So that site is, we have the .NET Framework team wrote a series of examples of how to containerize existing applications, and they have this thing called the eShop demo. And it's an ASP.NET Web Forms and MVC solution that you can go and get from GitHub, work through a series of labs and samples, and work through the process of making sure that that's containerized. So that site actually hasn't come up yet, and that's not running. So with the new portal drop that we did on Monday, you can now see the container logs within inside container settings. So we'll just wait for the UI to spin up. And you'll see here at the bottom, I can see what's going on currently on that worker. So it seems we're still in the stage of extracting the image. So when we do a Docker pull, there's two, for those of you who are not familiar with Docker, we do a pull, we pull the image, but it comes down in layers, which are zip files, the equivalent of zip files. And then we have to unpack them, and then we build the container when we do the Docker run, and that's how that works. So this gives you an idea of what's actually going on underneath the hood. It's a shame this one hasn't started, because what I wanted to show you was a lot of the benefits that you get with inside Azure App Service just light up. So application settings. You can now use web config, etc. Simple things that you're used to, environment variables, application settings, connection strings. Manage them via the portal or via Key Vault or whichever method that you wish to use, and we can inject those values in at runtime. So the one that I was actually hoping to show you there is that we're using a connection string off to a database that's hosted actually in this instance on an ACI instance, and then we're calling it in from another service. But that site's not up and running. It may be up and running by the end of, within a few minutes, but we'll try. One of the other things that I wanted to cover is installing into the GAC. So having an MSI or an exe, well, how do I execute that with inside my container? And it follows the same pattern as the previous one. This example you're seeing is something that I expect to see a lot of our customers, is internal applications that are built in ASP.NET 2.0 or earlier, and call into an access database. I managed to solve this one way. This may not be the same for everybody, but this is one way that I managed to solve it. And what I'm actually doing here is I'm installing the Jet library. So let's go to the access database sample. The web app is very similar, except it's just a .NET 2, which is why you can see there's very little else to it. There's the default ASPX. I've got the access database in sample in app data, and all I'm doing here, same as before, is I'm doing a pull from storage. So I'm getting a request, pulling down from a storage account that particular exe, and then I run it on the machine. And you'll see in the Docker file there's an arguments/q. For most MSIs and exes that install components like database clients or component suites, that sort of thing, then they will have a silent installer. So the silent install is your friend in containers and Windows Server Core because you want to do it in a non-interactive mode. You don't want to have to get prompts and deal with them because there's no way of dealing with them. And then finally, this one also points out another thing that you need to do. So access applications, certainly with the Jet library that I'm shipping it with, need to enable 32-bit on the application pool with inside IIS that's running inside the container. So that's another step that we need to run on this. So at the bottom, configure the IIS application pool for 32-bit applications. So here we can use a tool called app command that's been available in IIS since version 7. We can use that to enable that feature. Top tip, if you need to use app command to do anything, the IIS management tool, the IIS manager, when you go into configuration editing, has got a tab for generating the script. And it gives you the tool on how to generate the script in C#, I think JavaScript, PowerShell, and app command. So you can find out how to do this thing when you need to modify on a server, but you're trying to work out how do I do that in a container. You can generate the command and off you go. So that's that one. Let's dive in to too many windows. In addition, our Linux colleagues yesterday announced support for mounting Azure storage to a web app. So one of the things that we've been asked for a long time is I want to add additional storage to my web app, but you guys have got a limit of 250 gig or whatever. Why can't I just use Azure storage? By default, we've never stopped you using the Azure SDK to do it, but now we're just going to mount an additional drive. So one of the things that we've done here is it doesn't show up in the portal. So I'll show you the blog post. There we go. So yesterday we announced bringing your own storage to Azure App Service. We have this capability already in place for Azure Files with Windows containers, not Azure Storage. But if you want to use Azure Files with inside Azure Storage and mount a drive and then host some content on that, what we do is we mount that drive with inside your container. So therefore, we can reach out to things like databases. Because obviously, if you put your database inside your container, like I did initially, and you scale it out, then you're just going to get replicas. You're never going to see anything persisted and stored and that sort of thing. So putting data in a container in that manner with an application is dangerous. So here I'm actually pulling a data file from my Azure Files. So that's quite a very new feature that we've just launched in Linux, and we've already got feature parity in Windows containers. And so the access one we've gone through, let me just do a recap. We've done custom fonts, done PDF gen, custom cultures. GAC assemblies are the same as doing with an MSI for a DLL and that sort of thing, because you need to package your GAC assembly up in an MSI and then install and execute. So there we go. "21 minutes. Okay. So with Linux containers, your remote access option is SSH. So you can SSH into the container and work with it. In the Windows world, most admins are actually familiar with Windows remote management. So we've enabled Windows remote management with inside containers. And you don't need to do anything for inside your container to make it work. We do it for you. We inject a module at runtime, and then we're able to enable WinRM directly into the container. And to do this, it's a turn on. And then what we do is we use, let me switch. Sorry. So with inside the portal, you go to your application and you go to the WinRM blade. And it's a case of toggling on to WinRM. And then you can copy out the PowerShell to do that and then access. Now we do have experimental support for the PowerShell. And I realize I'm running out of time here on the stuff that I do want to cover, so I don't want to spend too long with this, but if I can, yeah, okay. I'll demo that one at the end if we have time. But what this functionality does is it enables you to copy this snippet out, and then I know why. Just a second. Run as admin. No, it's not fair. Right, I'll do that at the end of the session if I have time. The one caveat with the WinRM stuff, and that may be why that's not working, you do have to restart the site once you enable it. So if it's something that you're interested in playing with right now, deploy your site, restart it once that flag's set before you need to use the WinRM. We are working in our backlog. We're still in public preview. We're working on being able to do that without you having to restart the site, but that's the way it is currently. And that's valuable for troubleshooting, things like that. So you may have things working fine on your local machine, but then you see a quirk when you go to us. You shouldn't, because that's supposed to be the value prop of containers. But if you then need to dive into the container and look at some application-specific logging or whatever else that you haven't log shipped off to somewhere else, then that does give you that capability. Tweak IIS settings, that sort of thing. And now, let's try and do the full shebang demo. So let's go back to the slides, the deck. I'm just going to close down a number of these tabs because we don't need them. And I'm going to go through full CI/CD pipeline with the web app that we created earlier. So let's go back to this one. And what I want to do is I want to add the solution to source code, source control. Where's it put that? And so I'll just get it to, oh, everything's gone stale. I do apologize. Just do my two-factor FA. Come on. I've got, have I got any Brits in the audience? No, okay. I do have a Blue Peter style. Here's one I made earlier type version of this if this doesn't, if this takes too long. Because actually some of the content that I'm coming up with next is very valuable. Yeah, I'm going to dive out. So this is one of my Azure DevOps. Yep, I have been practicing. And so in here I have a repo, and it's just a simple web application to Docker. Here you can see the code in my repo, simple web app tests. All it is just another hello world site. And what I've done here is I've committed my source code up into Azure DevOps to my repo. And then I built a pipeline. So if we edit the build here, we can see that I'm just doing standard build tasks, build solution. I want a Visual Studio to build my project, run my tests, publish my drop. And then the key steps with Docker containers is you need to have two steps. One is to build. You want to build your container, and the second one is to push. So in this instance, I'm just doing a build of an image, and then a push, and I'm setting that to use, let's make a change. Let's set it to use the latest tag on both. I'm a little concerned why it's not pulling in my subscription, but let's just make sure that that's good. Yep. And there we go. This one as well. Yep, done. Let's save and queue. And that's going to build all of my code, run my tests, build my containers, and then push them to Azure Container Registry. Now what I can do is I can go in and create a web app, and I'm going to show you a different creation flow. So you can now just go and pick create a web app. You don't have to go through web app for containers. So let's do ignite CI/CD demo and choose Windows, choose a Docker image. Now for this one I am going to choose that PC4 that I had earlier, and we're going to configure the container, and this time I'm going to use ACR, but the difference is here is I haven't gone through the web app for containers where you only get container options. I've actually gone through the new web app. This is a new flow for the UX that we've put in place this week, so feedback is more than welcome. If there's edges that you don't like, it's a bit if it's confusing in any way. On this tab you will see two other options, Docker Compose and Kubernetes. So in Linux we have the ability for you to provide a Docker Compose file or a YAML file for Kubernetes just to describe your application to do multi-container deployments. On Windows containers we only support single container deployments today. So let's go and do ignite practice. We'll get tag 69, which was my original build, and we'll apply that. And we create. Okay. So that's going away, creating the site and doing the Docker pull to pull that image down. What I also want to do on that application, let's check how that build's going. Here we go. So we're waiting on the build agent. Okay, so we're building, fine. Okay, we'll come back and check in on that in a second. So what I want to do now is go into, so there we go, we've got the resource, created this time. So what I'll show you here is the flow. You would see when you create a web app with a container, you will see this blue screen. You'll see your web apps starting up, and it's just to give you the feedback that we're waiting on the Docker pull to complete, and then we push that up. But what I want to show here is I want to go and do deployment slots. So I want to go and add staging. And I don't want to clone the config. I do want that in place. Just let that create. Right. And our deployment slots are brand new sites. So they're another site within inside the app service plan. So what I can do now is I can choose in that deployment slot to either pull from container registry or pull from somewhere else. So it may be that part of your build process that you actually push your production images up to ACR, but you push your dev test images into Docker Hub, or vice versa, or some other place, custom registry or whatever you wish to choose. For this, we'll do container registry, ACR, and just to show that they are different, I'm just going to do custom font sample, and I'm just going to choose latest, just to show that we end up with two different images, and we'll do save. And what will happen then is I will get two different sites with two different, pulling from two different containers, and they will spin up and they will be ready for us in a few minutes. In addition, you may have seen in the UI this piece, so webhook URL. So the webhook URL is important if you want to enable CI/CD on the actual slots itself. So the webhook can be registered into your container registry for us to be notified whenever anything changes. In the same way as we have the webhooks for your source control options if you're doing app service with code, we can do the same thing for containers. So the URL is valuable when you do this with Docker Hub, because in Docker Hub you go into the image and you configure the webhook, and this is the URL that you need. If you set continuous deployment setup with an ACR repository, we create the webhooks for you on the backend ACR, so you don't need to go and do that manually. You can in ACR change the scope so that you can say, well, I don't want it to trigger on the whole repository, I want to trigger it based on the image, and so on. So that's what happens there. So let's see where we are with those two. So we're still waiting for those. Okay. While we're waiting for those, because they do take a little while because they're server core containers, I could have cheated and done nano, and they're tiny, but I wanted to do real life examples. So what I'm going to do is I'm going to go and finish the rest of my slides, because there's some important information that I do want to impart to you today, and I think it's valuable. And then we'll come back and close out the demos in the next few minutes afterwards. So let's bring it together. So what is a container and why should you care? So traditionally, virtualization took point of traditional virtual machines. So hardware virtualization. Sat on top of a hypervisor or other equivalent, and you had your application in your OS, but they were hosted inside virtual machines. You had multiple virtual machines, etc. And the idea of containers is that they're operating system virtualization, so that your containers sit on top of a kernel, and then you have multiple processes running outside and inside the container. Windows has two different options: Windows containers and Hyper-V containers. So Windows Server containers are more analogous to the way that Linux does containers, in that they run on top of a shared kernel, and then your containers run on top. The downsides of using that type of container is you don't get the security isolation boundary. There is the potential to be able to, because it's a shared kernel, there is the potential as a noisy neighbor to exploit the shared kernel and attack the other containers. And in addition, because they very much need to run on a shared kernel, the containers need to be built off the same base image, so the same version of Windows that you want to run your container in. We run a version of Windows in Azure that you can't easily get access to. So us to choose that option, regardless of the isolation boundary, would be a bad choice, so that we didn't choose that. The Hyper-V containers are slightly larger and slightly more overhead. However, they provide you with a different isolation boundary, which means that we can get away from the sandbox restrictions that we went through earlier, and I've shown you through some demos. And they have their own instance of the kernel inside the container itself, and they just run on top of Hyper-V. So that's why we went down that route, and that's what we chose. So that's the key difference. When you're running containers in Windows containers in Azure App Service, what you're actually running is a Hyper-V container with an app service. And the anatomy of a container and why this is important. I can't stand seeing the shipping containers everywhere where we're talking about containers, right? You know, I go and see them on the back of a Maersk ship. That's where I want to see them. I'm back on any other big container ship. That's where I want to see those. So I did think about using a Tupperware box, but the graphics people kind of talked me around, so there we go. Application layers is what you're injecting, your application layers, and this will be common for you. And then you may have prerequisites or customizations, like I showed with installing database clients, custom cultures, GAC libraries, that sort of thing, and they will go in. And then below that, you've got your base OS. And just to call out again, once there we go, that we support those versions. We are looking at how we can get to be able to support the newer ones. So therefore, we reduce the container size. We get a lot of other benefits, but we're not quite there yet. We are a very big service, so it takes us a little bit of time to make changes. But the layers are very, very important. So you may have seen pop up the DOS prompt when it was building the container and building all of those different layers. And I had about 13 different layers. And this is why it's important when I went through the the delete the dependencies folder. You don't want additional layers if you can possibly help it. Every run command, every copy command, every add command that you have in a Docker file is building another layer. So if you can combine them all like I did with PowerShell and just run one command to do everything, then that's the way to go forward inside there. The other step that you can go through, which I didn't go deep into with this one, is there is also multi-stage container build. So you can build a Docker file that does multi-stage. So you can do from multiple base images, and that can result in a smaller image as well. So some best practices for Windows containers, and these are the things that I've learned as I've been learning with Windows containers and doing more work. And I'll be open and honest. The reason I love being in tech and development is because every day is a school day, right? So every day I'm getting schooled on something new and something better to do. And this is what I've gained based on our documentation and based on the experience with Inside Corp. So choose your base image carefully. You are stuck with .NET Framework using Server Core. You are stuck with Nano using for .NET Core. Well, .NET Core you can use either, but seriously you want to be using the Nano image. Choose the cached images in order to benefit from the speed of us already having those images on our workers. As soon as we stand up a new worker when we roll out a deployment, we do pull those cached images and then we refresh them. Layers, going back to the separate step and also to my demos, minimize the image layers. Don't put additional things in there, additional steps that you don't need. If you do work with dependencies, install your dependencies and then get rid of them, because you don't need them. The actual layer above has been modified. You don't need those intermediary layers. There's some documentation on docs.microsoft.com around Docker file optimization, principally around Windows images, so please check that out. Group-related actions, which is what I did with the PowerShell. Remove excess files, we did that. Build speed. Your Docker build will be slower depending on how detailed that Docker file is. So if you can split it into multi-build or you can combine it all in one process, then off you go. Ordering of instructions has an impact on your Docker file. And then there's cosmetic optimization. So you can label each layer so that you can see what's going on when you do a Docker build and make changes. So in summary, because I've got 3 minutes left, Windows container support in Azure App Service is in public preview, and we're really excited to see what customers do. Please try and push us as far as you can. We are very, very interested in your feedback. Does it solve your problems? Is it at the right point? Are there any features that you need, particularly out of the app service stable that you need? Which ones are we prioritizing? We are prioritizing things like VNet support and things like that. MSIs, we're hearing that one loud and clear that people want MSI. It offers new application modernization and migration possibilities and key capabilities during the public preview. Single container support, deployment slots, CI/CD, so you can publish and configure a webhook and we'll go and get the new image when you tell us to. Automatically, you don't need to go in and change the settings. We've got integration with VSTS pipelines, the release pipelines. The one hiccup that you do have with the release tasks is the release task to publish to a web app for containers only supports Linux today, but we'll work with the DevOps team to fix that one, and we'll get that one going fairly soon in the public preview. Easy auth, being able to not have to worry about authentication at your application layer, but we deal with it on the external. So being able to spin up AAD authentication, MSA authentication, Google, Twitter, Facebook, off you go with a couple of clicks inside our portal. Scale, we are global. We've added 6 stamps now, and in some of those areas we've added 2 stamps, so we've got more region support. We can go to a high scale for you. WinRM gives you new capabilities and new powerful SKUs. So if you've been restricted from coming to App Service because of the sandbox, because of the unavailability of being able to install dependencies, or our VMs are just not powerful enough for your application, now you've got new choices, new options. Containerize your application and come along and take a real look at App Service and the value. I moved 4,500 miles to work on this product. I'm really passionate about this product, and I think it solves a lot of problems, and I don't think it's something that a lot of our competitors have out there. A true PaaS offering for web and application hosting. It's really powerful, and it's fun to work on. I have got some time for Q&A, but I'm also going to be on the booth all week, and I will be back here for a few minutes. I will get my gear off the stage quickly for the next speaker. Check out some other app service sessions at Ignite this week. The one yesterday, best practices on getting the best out of app service, went down a storm on the theaters. Please check out the recording. My colleague Christina, while I was talking, she's been talking about the networking enhancements that we're making in app service to bridge the gap between app service environment and app service. Very valuable session. If you've got some time, please check that one out on the recordings. And then at 4 o'clock, my colleague Jennifer Lee is going through diagnostics and Azure App Service, which is another very, very valuable session. Thank you very much for your time and listening to me. I hope you found it valuable. I welcome your feedback through the evals. And any questions, I'll take them now before I go. And otherwise, please come and see me on the booth. I'm there all week. And thank you very much, and just have a fantastic Ignite.